Let us continue with the concept of potential and the flow of charges or electric current. So we were saying that when we have a source of energy such as a battery, and we mentioned that we can have the electric potential or voltage in a positive or negative instance, and all depends on where we locate our ground. So in this particular setting, we have a set of batteries in series, and we know they're in series because of our negative point is connected to our positive point, one next to the other, so in series. And in this case, when you connect batteries in series or power sources in series, you get the potential to increase linearly. So if each battery is 1.5 volts, which is this is a typical battery, and you connect four of them in series, then you're gonna have 1.5 times 4, which is 6 volts, right? Because then you have 1.5 plus 1.5 is 3. Then the third battery will be 3 plus 1.5 will be 4.5 plus 1.5 will be 6 volts. So by having four batteries in series, you have a potential of 4 volts. And when you connect your load or your light bulb to the battery, you'll have higher um, power, you will have higher intensity, obviously, when you have a higher potential, because we will see that the power is going to be voltage times current. And we already know that the voltage increased 4 times. So this is pretty much the circuit for a flashlight. You have an enclosure that you can 3D print or make out of plastic. You're gonna have a switch to turn the battery or the light flashlight on and off. And closing the circuit with the switch, you're gonna have the batteries in series. The load is the light bulb. The circuit is closed at the batteries with the springs, and just a plain circuit would be this type, where you have a light bulb, your batteries connected in series, the ground is not in the middle, otherwise we'll have negative zero point 0.5 and positive zero point 0.5. You have the ground at the bottom of the first battery, and then the switch is closing the circuit. We can create this circuit by, if we go to our, let's see, let's go back. If we go to Tinkercad, you create a circuit, you know that you can create an account with your college ID for free. Tinkercad is an open source version of a software developed by Autodesk, and Autodesks are the same ones that have Fusion, AutoCAD, Autodesk. Sorry, Autodesk is the company that has AutoCAD and Tinkercad and Fusion and others. So if we want to do the battery circuit, first of all, we have to log in, and you can have a 1.5 or a 9-volt battery depending on the size of the battery. We're gonna have, let's say 2, but you can have 4 or 8. It really depends. It could be any type of battery or any amount of batteries. You can have up to 12 if you want. But now what we want to do is connect them in series. So if we could, we would connect this on top of each battery, but this is not how they designed the software. So we just need to connect the positive lead to the negative lead, and that is basically how you connect the battery in series. And we want a light bulb, so light. Let me see what kind. Oh, there you go. Well, you have this one right here. There you go. We've rotated with R. Just press R to rotate. And then we close our circuit with our wire. So now this is connected to the battery. And since this is connected to the negative lead, we're going to have this black. Okay, so if we run the circuit, we have the light bulb turning on. Now, if we want to measure the voltage, we simply have to bring a multimeter. And what we can do is have a multimeter placed here. So let's see if we connect this point to this point, and this positive point will be red, and then we connect this point to that point. We don't need to break the circuit to measure voltage. We want to measure voltage. So if you notice, if you measure current A, it will show you something like an open circuit. You will not have a true value. Well, you can measure voltage by placing the probes at the end of the resistor, or before and after the load, and it's saying it's 2.94 because of some the software is assuming some type of loss because of the light bulb, but truly it should be 3. In fact, if you get rid of this wire, get rid of this wire, and get rid of this wire, and you connect your multimeter in series with the circuit, like so, and you measure your voltage, then you're gonna have your 3 volts, like so, and then you can get the true value of the current, which is in milliamps, because these batteries will never be able to get such high amperage. Will never get to 1, 2, or 3 amps. That is a lot of amperage. These batteries usually have milliamps. Okay, so this is how you measure current. You just place your probes in series with the circuit. Okay, so back to this. So basically this is what we did. We have, oh, actually we didn't have the switch, so we can do that too. So now we know that the voltage is 3 volts because we're in series, so we don't need this multimeter. We just need to have the switch installed. And what type of switch can we use? They don't have a lot of different types, so I guess we can use this one right here. And in that case, we just need to place, this is a 3-place switch, but we're only going to use 2. So we're going to connect to the common, and we're going to connect to here. Let's say this is red, since this is positive before the load, and this is red. So in this case, this is not going to work unless you turn on the switch. So there you go. This is pretty much the circuit, the same circuit we have right here. Okay, so that the battery that we just talked about is a power source, but we also have more, I guess, fancier power sources which you actually connect to the socket, the wall, this guy will have a connection to AC power. And in here they have rectifiers and diodes and a lot of stuff that will rectify the voltage to DC. And you have, depending on what the equipment you buy, you have from 0 to 60 or 0 to 100 and up to 1.5 amps or 5 amps. Actually, there are power sources that are pretty expensive, and that could be 60 volts and 40 amps. This is the type of batteries that they would use for starting cars in test cells and research for testing. So for instance, the car battery, that type of battery, which is not the same battery that we talked about. If you're familiar with car batteries, these are 12 volts, but they can have a lot of current. In fact, when you turn on the car, that is why it could be dangerous to jump batteries. If you don't know how to do it, make sure you're being safe and asking somebody to help you. Because when you turn on the car, that instant, when you turn the engine on, you can have a spike up to 50 amps. And 50 amps are extremely dangerous. Okay, but that's different than regular AA or AAA batteries. This is a special case. And this is only for instance. It's not a steady 50 amps. This is only for the instant of turning on your car. Okay, but back to this. The power sources that you use in lab equipment or lab setup is pretty fancy, as I was saying, because you can have different types of voltages, different type of currents, but it's very, very precise. You can have 21.2, 21.5, 20. You can have very specific voltages for your equipment. And this is used to tune, calibrate, design circuits. And it's the same thing. You would have a positive source, you would have a negative source, and you have a ground or common. Typically, if you want to have negative voltage, you use your ground and your negative lead and connect to circuit to these two inputs. If you want positive voltage, you connect your positive point to your ground to your circuit. So you can close the rest of your circuit with resistors, capacitors, whatever, to your positive and your ground. And this is a good example right here. If you want 10 volts, positive 10 volts, what you do is typically create a jump between ground and negative, meaning that the negative point is going to be 0. So basically, you would have your potential starting from 0 and going back to, with the knob, you set up your 10 volts. And this is pretty much the voltage that you will use for your circuit. So if your power source has 3 points, you remember that you pretty much just use your positive and your negative, or if you have more than one power source, you jump your power source with your ground. Okay. Now, when it comes to current and voltage, we already know that voltage is a potential from ground to the highest voltage that you get. For one circuit, you can have circuits that have combination of 24 and 28, and this is DC. We're talking about DC voltage. You can actually have 5 and 12, or 5, 10, 12. You can have all sorts of voltages, but they have a common return to ground. So some stuff will use 5 voltage, some stuff will use 10, some things will use 12, sensors will use 28, some instruments will use 28, and some other instruments will use 24. So it is very important that you recognize what is going to be the flow of current through your circuit. By convention, the current magnitude is the same if you're going from point A to point B, or if you're going from point B to point A. But in general, you have to decide if you're gonna balance your circuit, which this which how do you say which direction will be positive and which direction will be negative. This is you, the designer, who gets to decide this. But once you decide a direction, everything else has to follow that convention. So if we say that the flow of current from A to B is positive, anytime in your circuit that you have a flow of current from B to A, that has to be a negative current, and basically will subtract from other currents throughout your circuit. Same from voltage. By convention, the voltage from negative to positive is positive, and you can have from positive to negative, it will be negative. Of course, we have the same case, the magnitude of the voltage is the same. Now, as we saw using Tinkercad, you can use voltmeters, and the concept for measuring voltage with a voltmeter is that you simply place your probes, your black and red probes at the points on the circuit that you want to measure your voltage, and you don't have to break your circuit. You can just place the probe at two different points. If the voltage is the same, then you're measuring the same potential. If it's a different voltage, then you're throughout you're measuring a difference. Yeah, you're measuring a potential. In other words, assume that we have this circuit right here, where this point right here, if you notice, follow this wire is connected to ground. Okay, so if you measure with your voltmeter, with your probes, here and here, it will tell you that the voltage is zero. It's because these points are at the same potential, even though this point could be on a wall and this other point could be on the roof. They could be very far apart, but if they're connected to ground, they have the same potential. Okay, but if you measure from here to A, it will be 3 volts because you're going from ground to positive 3. Now, if you measure from ground to point B, it will give you negative 3 volts because you have what is called polarization. So electric potential is polarized in a way that that's why you have a red probe and a black probe, because the black probe is supposed to measure the neutral or the common or the negative voltage, and the red probe is supposed to measure the positive voltage. So as a rule of thumb, always place your black probe on ground and start measuring your potentials with a red probe. That's why here, if you place your red probe here at this point and your black probe on B, you'll have negative 3 volts. Okay. Now from here, you have ground and C. This is positive 3 volts. From ground to D is positive 3. From ground to E is also positive 3, because we have a negative here, a positive here. The difference on point B was that we first have the positive. So that meant that we changed polarization. Now, if you go from ground to point F, we have positive 3. Then if we go from ground to point G, we have positive 6, because it's 3 plus 3. And if you go from ground to H, we have positive 9 volts. All these points from ground to H were in series. Now we came to a very important point, one of the key points or most important points in this class, which is power energy. Everything is building up to the concept of power, and for DC, the units of power are watts, In AC, you can have watts, which is short for is W, and you can have volt ampere. And once you take AC, you'll see why, but basically it's because in AC you have something called reactance and impedance, and because of those two concepts, there's some apparent power and some power factors that come into the picture, and it's not so efficient. Where for DC, all the voltage and current that you use will go to power, but AC, there's some power that is not useful because it's used for basically for electromagnetic forces and things that are not mechanical forces, or are not useful in a mechanical way. But you'll learn about this in AC. For DC, the units of power are watts, and watts are basically joules per second. So joules per second is the same thing as watts. The same thing as when you have force equals mass times acceleration, and mass is in kilograms, and acceleration is in meters per second squared. Instead of saying kilograms meter second squared, you say newtons. Well, the same thing, watts, instead of saying joules per second, you use watts. The unit of power is volts times current. Voltage times current. Okay? Now, in general, you can also have positive or negative power, and this basically means that either your circuit is giving away power or is consuming power. And the rule of thumb here is just following your signs and your directions. So if you have a potential from negative to positive, then in your current is flowing from positive to negative, and you assumed that it was positive, then your power is going to be positive. 12 times 2 is going to be 24 watts. Now, if you have another case where you're going from ground to positive and your current is flowing through your load from the ground to your positive potential, and you assumed that that direction was positive, then you can also have positive power. But if you assumed that your currents were flowing from positive to negative, and then in a specific branch or a different part of your circuit, you have a current that goes from positive to negative, in a way that your ground is now here on your positive potential, then you'll have a negative potential, right? Or you can have a negative current. Since power equals voltage times current, you can have a negative value, either your current or your voltage. It should be really voltage, but the book said it's a negative current, but truthfully, it should be a negative voltage because voltage is polarized. So in this case, you can have a negative voltage, therefore, you can have a negative power. So negative 36 watts, 12 times 3. In case B, for instance, we noticed that if we had a current flowing from negative to positive as well, we had a negative voltage. So this is, I didn't mean to get you confused. In other words, if the convention was that anything flowing from positive to negative was positive, then in case B, when you have a flow of current from negative to positive, this will be negative because of the voltage going from negative to positive. Or you can have negative current if you have that your current is going towards your ground or your negative point. So it could get confusing, but that's why it's important that you always follow the same nomenclature. So a particular example, I always like to say that, for instance, this is a resistor, and I'm going back to the battery, right? So I always like to assume that from negative to positive, I'm going to be flowing in a clockwise direction with a positive voltage. Now, this is going to be very useful to get familiar with this concept, because when we start having circuits with branches and other sources of power, then you might have currents going the opposite direction. Okay, and in that particular case is where we have to say, oh, this current is going to the right, but this current is going to the left. So which one is positive and which one is negative? As long as you follow a convention, you'll be okay. So in this example, the book decided to have the convention where from positive to negative is going to be a positive current and a positive voltage. So if you go from negative to positive, you're going to have a negative voltage. And if you go from positive to negative in a potential, right, then you have a negative current. So once we have examples, it will be much easier to understand. For now, more than the signs and anything else, the important thing is to remember that the formula for power is voltage times current. Now, by measuring with a multimeter, let's go back to the battery to show how we can measure polarization with a multimeter, and we get back our light. Let's say we're going to use the same light bulb, and we can only use one. We don't need more batteries right now. We can just use the multimeter. So go back to get our multimeter. There you go. So if we close this circuit where we have a positive point with red and a negative point, we're gonna have black. Okay, so first of all, without the multimeter, we can still get the circuit to work. But if we want to measure voltage, then the only thing we need to do is, and we did this before, we connect our positive point to the point of interest, so the battery, and our negative point to where we want to measure the potential from. So if we measure right here, we're going to measure 1.5, well, it says 1.48, which sometimes, as I said, the software Tinkercad is designed by the engineers to show some loss by running the circuit, because the load right here will have some, turn to heat, and it will have some inefficiencies. But very likely when you get an actual multimeter, you can pretty much measure 1.5 volts, or sometimes you can measure much less, really, depending if you don't have good contacts. But the point here is that if you want to measure the voltage, you simply put your prongs right there, your probes right there. Now, what we said before is if you measure your potential from the negative point instead of the positive point, so you go back to black, we're gonna take our black point to our positive and our positive to our negative. Let's say this is red. When you measure, this is going to be negative 1.48. That is because, as we said before, by switching the polarity on the measurement on the device, you can actually get a negative reading. So this is the same thing when you do calculations, you have to assume, or you can pretty much, say, okay, from negative to positive is going to be positive. If I were to get something reversed or measuring current in a reversed fashion, or if I get a circuit that is flowing from ground to negative, then that could be a negative voltage. So it's pretty much up to you how you measure, how you going to measure your voltages and your current. But remember that you can get reversed values depending on how you measure your points. Now, power and energy, as we said, are related by time. So energy is in joules, time is in seconds. So power is the rate of energy in time. So evidently, we can have the amount of power in a specific amount of time. And we can do integral, or we can do a subtraction, or we can add, or we can divide by time steps. We can do many things, but the important thing to remember is that the power is a function of how much time the circuit is on. So, for example, since the formula of power is voltage times current, and they're telling us that we have a specific function that is 12 times 2e to the negative t, this circuit has t as a variable because it depends on if the circuit is on for 2 minutes or the circuit is on for 2 years, for example. Okay, so 12 times 2 is 24, e to the negative t watts. If you integrate this, you're gonna have basically you can assume any time, say 35 seconds or 2 hours, whatever it is. But assuming that it's from 0 to infinity, that the circuit is always on, then the integral of this function is negative 24 e to the negative infinity and e to the 0. So these two guys tend to go to 0. So the energy is 24 joules. This is one example that I wanted to show you one time, and hopefully one time only, because we're not gonna have a lot of integrals. Actually, I don't think we'll have any integrals because my goal is to have the circuits and the examples and problems more in terms of actual hardware, such as resistors, capacitors, inductors, etc. But I wanted you to know that if you decide to go for engineering or for physics, you'll have to see these things again because the power is indeed a function of time. If you remember that electric current are charges flowing through an area given a specific amount of time. Okay, so that's why we have power as a function of time, because electric current is a function of time. Now, we also saw that the difference between DC current and AC current is that AC current is fluctuating in time, it's a wave. For instance, the AC current that we get in our house is 60 hertz in US, is 50 hertz in Europe. So it's basically going up and down 60 hertz per second. We cannot see the light bulbs and things flickering because this is happening. This is going up and down 60 times per second. And well, for instance, if you see a movie, it's changing 24 frames per second, and we cannot even see the frames. So 24 times 2 is 48. This is more than twice. So if we cannot see 24 frames per second changing because our eyes are not able to capture those details, so obviously 60 hertz, which is 60 repetitions per second is way too fast for us to notice. But what is going on is the light bulb is turning on and off 60 times per second. So it's extremely fast. It's almost like DC to us, really, because DC is a constant power. So the light bulb is on all the time when it's DC. Versus for AC, a light bulb is turning on and off. This is a light bulb, right? This is the resistance on inside the light bulb. It's turning on and off 60 times per second. Right, so this is the other type of term. This is the resistor, this is the light bulb, and both ways will work, but DC will constantly on. In AC is turning on and off, but it is really fast. The other concept is how to measure current and voltage. We already saw that to measure voltage, you simply put the probes on the points of the circuit that you want to measure. But to measure current, you have to connect your meter in series with the circuit. So you have to remove a wire or break the circuit. Just removing wire and connecting your probe to close the wire they removed. So the electric charges are going to go through your meter so that you can measure the current.